students, in the previous video we already started the topic about group 17 elements. In that, the electronic configuration of the particular elements which are present in 17th group means halogens, then occurrence and some physical properties. In this video, I am going to explain some chemical properties of 17th group elements. Come to the point of chemical properties. Observe carefully, this is very important. This chemical properties of 17th group elements. In that, first one I take oxidation state. Oxidation state of 17th group elements. Halogens ಯಾವ oxidation state ತೋರಿಸ್ತಾರ. Students, in that first I write one point, that is all halogens shows minus 1 oxidation state. Yes, I think already you know, while writing Cl, Br, we write Cl minus, Br minus, I minus, is it right? It indicates, it exhibits minus 1 oxidation state. All halogens exhibit minus 1 oxidation state. And another point, halogens Cl, Br and iodine also exhibit plus 1, plus 3, plus 5 and plus 7 oxidation state. Yes, second point is halogens like Cl, Br, iodine, not fluorine, also exhibit plus 1, plus 3, plus 5 and plus 7 oxidation state. Next, another very important point, fluorine exhibits only minus 1 oxidation state, means it shows only negative oxidation state. Students, next point, higher the oxidation state of Cl, Br, iodine is with the elements like fluorine and oxygen. Higher the oxidation state of chlorine, bromine and iodine is observed when they are present with more electronegative atoms like fluorine and oxygen. Okay, students, so these are some points which observed in presence of oxidation state of the 17th group elements. Think what? Halogens. Okay, students, first come to the point of all halogens shows minus 1 oxidation state. Students, I think you know general electronic configuration of 17th group elements. Some electron ವಿನ್ಯಾಸವನ್ನು ನಾವು ಹಿಂದಿನ ಕ್ಲಾಸ್ ಒಳಗೆ ನೋಡಿದ್ವಿ. ಅಲ್ಲಿ ಏನಂತ ಬರೆದಿದ್ವಿ? ನೋಬಲ್ ಗ್ಯಾಸ್ NS2 NP5. Is it right? ಎಲೆಕ್ಟ್ರಾನ್ ವಿನ್ಯಾಸವನ್ನು ನೋಡಿದಾಗ ಅಲ್ಲಿ ವ್ಯಾಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ನಲ್ಲಿ ಟೋಟಲ್ 7 ಎಲೆಕ್ಟ್ರಾನ್ಸ್, 2 plus 5 ಟೋಟಲ್ 7 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದಿದ್ದು ಕಂಡು ಬರ್ತಾ ಇದೆ. ಹೌದಾ? Let's see here, in presence of S orbital there are 2 electrons, and in presence of P orbital there are 5 electrons, means according to the Ohm's rule, first they occupy, means singly occupied, then it becomes paired. Yes, 4, 5th electron. Yes, when you observe this electron configuration, it contains one unpaired electron. Students, I write one very important point here, this third one. Fluorine exhibit only -1 oxidation state. What is the reason behind this? Why fluorine shows -1 oxidation state only? Remember students, when you write the electronic configuration of fluorine, it contains one unpaired electron, and you already know it is one of the more electronegative element in the periodic table. Most electronegative element in the periodic table. And it requires only one electron to get the octet electronic configuration or octet noble gas configuration. ಈಗ ಇಲ್ಲಿ ನೋಡಿ, ಇದು ಇಲ್ಲಿ ಒಂದು ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಹೌದಾ? ಈ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಈ ಪಿ ಆರ್ಬಿಟಲ್ಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ಡ್ ಆಗಬೇಕಂದ್ರೆ ಇದಕ್ಕೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಅವಶ್ಯಕತೆ ಇದೆ? ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್. Therefore, it always try to accept one electron. ಅದೇನು ಮಾಡ್ತದೆ? ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ತಗೊಂಡು ತನ್ನ ಆಕ್ಟೇಟ್ ಕಾನ್ಫಿಗರೇಷನ್ ಪಡ್ಕೋಬೇಕು ಅಂತ ಹೇಳ್ತಾರೆ. Remember why fluorine shows -1 oxidation state? Because it accepts or it required one electron to get its octet electronic configuration. And in some textbook you observe, because of no vacant d orbitals or because of small in size or because of more electronegativity. Remember students, fluorine is one of the more electronegative element, therefore its oxidation state is only -1. Okay. Yes. Similarly, all halogens shows -1 oxidation state. And second point, halogens Cl, Br, iodine also exhibit +1, +3, +5, +7 oxidation state. How do you flow this? See here. You know, general electron configuration in ground state of halogens is observed like this, in that Ns contain 2 electrons and in Np it contains 5 electrons. This in first excited state. Excited state means the jumping of electrons takes place. You know, ಈಗ ಇಲ್ಲಿ ಒಂದು ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಬರಕತ್ತಿತ್ತು, ಇದು ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾದ್ರು ಇನ್ವಾಲ್ವ್ ಆಗಿತ್ತು, ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಇನ್ವಾಲ್ವ್ ಆಗಿತ್ತು, ಹೌದಾ? ಅವಾಗ ಏನಾಗಿತ್ತು? +1 ಅಂತ ಹೇಳ್ತೀವಿ, ಹೌದಾ? Okay, next, ಈಗ excited state ಮುಂದುವರಿಸ್ತಾರೆ. Okay, during this time d orbitals are vacant. Yes, see here, in post excited state what happens? Here I take this ns orbital, as I write same, and again 1, 2, 3. This is about np orbital, and d orbitals, you know, there are 5. 1, 2, 3, 4, 5. Is it right? Yes. Students, here 1, 2, 3, 4, and 5 np orbitals. But in first excited state, one of this electron is migrated towards to d orbital. In excited state, one electron in the orbital is the electron jump out. Okay, ಹಾಗಾದ್ರೆ ನಾನು ಏನು ಬರೀತೇನೆ ನೋಡಿ, ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿ ತೋರಿಸ್ತೇನೆ, ಇದನ್ನ ಏನು ಮಾಡ್ತೇನೆ? ತೆಗಿತೇನೆ. ಇದು ಯಾವಾಗಿದು? ಫಸ್ಟ್ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್. Yes, now the number of unpaired electrons present here 1, 2, 3, therefore it shows +3 oxidation also. Next, second excitation state, excited state. Yes, during this time this one electron migrated towards the another d orbital. As see here I write the orbitals. Okay, now I move this electron to this orbital, therefore I write here only unpaired electron, and here this one of d orbitals 1, 2, 3, 4, 5. Yes. Okay. Therefore, here how many unpaired electrons are present? 5 unpaired electrons are present. Next, in the third excitation state, this ns orbital electron is migrated to another orbital, p orbital. Yes, during this time here I write only 1 electron, and here 3 electron, 1, 2, 3, and here also among 5 d orbitals, 3 orbitals. Okay, 5 electrons. Yes, now how many unpaired electrons are present here? 1, 2, 3, 4, 5, 6, 7. Therefore, this halogens shows +1, +3, +5 and +7 oxidation state. Okay, students, if you take some examples like HCl, HClO, HClO2, HClO3, HClO4. Now the oxidation state. Why I write these examples? Some compound shows +1, +3, +5, etc. oxidation state. As this example prove that concept. Okay, students, you know hydrogen oxidation state is always +1, is it right? Yes. And Cl is -1. Yes. In this compound, it shows -1 oxidation state. Here, oxygen oxidation number is -2, you know, and hydrogen is +1. Okay. When this overall value becomes equal to 0, you know it. Oxygen -2 ಇರ್ತದೆ ಅನ್ಕೋತದ. ಈಗ ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ +1 ಅದ. ಹಾಗಾದ್ರೆ ಈ ಟೋಟಲ್ ವ್ಯಾಲ್ಯೂ ಈಕ್ವಲ್ ಟು 0 ಆಗಬೇಕಂದ್ರೆ Cl ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಆಗಬೇಕು? ಈ +1 ಅದ, ಇನ್ನು +1 ಮಾಡ್ಕೊತೇನೆ ಅಂದ್ರೆ +1 +1 +2 ಆಯ್ತು. +2 -2 ಈಕ್ವಲ್ ಟು ಏನಕ್ಕೆ 0 ಆಗಿರ್ತದೆ. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಕೂಡ Cl ಅದ ಅಂದ್ರೆ ಹ್ಯಾಲೋಜನ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಜ್ ಏನದ? +1 ಅದ. Next, see here and calculate here. You know oxidation state of oxygen is -2. Therefore, 2 into -2 is -4. And hydrogen is +1. When this value becomes equal to 0, sir, ಇಲ್ಲಿ oxygen -2 ಇರ್ತದೆ. ಇಲ್ಲಿ ಎರಡು ಇರ್ತದೆ. 2 into -2 ಅಂದ್ರೆ -4 ಆಯ್ತು. ಇಲ್ಲಿ +1 ಇರ್ತದೆ hydrogen ಇದು. ಇವಾಗ Cl ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಾದಾಗ ಓವರಾಲ್ ಈಕ್ವಲ್ ಟು 0 ಆಗ್ತದೆ. As here +3 +1 4 4 equal to 0. As here the oxidation state of chlorine is +3. Yes, here when it is +1, 3 into -2 means it is -6. Is it right? As when it becomes equal to 0, when the value of Cl becomes +5. Next, here the oxidation state of chlorine is +7. Is it right? Yes, +1. 4 into -2 is -8. Yes. Okay, students. Next. See here, this point. Higher the oxidation state of chlorine, bromine, iodine is with more electronegative atoms like fluorine and oxygen. Yes, see here. Take this example. Are those IF5 and IF. Here the oxidation state of Cl, iodine is with fluorine and oxygen is the point. How we flow this? This example shows that concept. Students, one point is there is about fluorine. Fluorine exhibit -1 oxidation state. Why? Because of more electronegativity or absence of d orbitals. Students, see 5 into -1, that is -5. Therefore, iodine oxidation state is +5. Here 6 into take again 7. 7 into -1 -7. Therefore, it is +7. Okay, students, this is about the oxidation state of halogens. Remember the concept? All halogens shows -1 oxidation state. Chlorine, bromine, iodine also shows +1, +3, +5, +7. Sometimes some of the compounds shows +4 and +6 oxidation state also. If you take BrO3, observe here oxygen, you know, BrO3, 3 into -2, it is -6, therefore its value is +6. Why I take BrO3? Here the oxidation state of bromine is +6, and you also know down the group here it is the more electronegative. BrO3, 3 into -2, then is -6, therefore Br oxidation state is +6. Okay students, next another point, that is second one, reaction with hydrogen. Reaction with hydrogen. What happens when halogens react with hydrogen? Okay, students, observe this point. Halogens react with hydrogen. Halogens reacts with hydrogen. Hydrogen forms the hydrogen halides. Yes, ಏನಾಗ್ತದೆ halogens hydrogen ಜೊತೆ ಪ್ಲೇನ್ ಒಳಪಟ್ಟಾಗ ಅಥವಾ ರಿಯಾಕ್ಷನ್ ಒಳಪಟ್ಟಾಗ ಏನು ಸಿಗ್ತದೆ? ಹೈಡ್ರೋಜನ್ ಹಲೈಡ್ ಸಿಗ್ತದೆ. And these halides dissolve in water, and these halides dissolve in water forms hydrohalic acids. Yes. What is the point? Halogens react with hydrogen. They form hydrogen halides, and these hydrogen halides are dissolved in water. Then it forms hydrohalic acids. ಏನು ಮಾಡ್ತಾ ಹೈಡ್ರೋಜನ್ ಹಲೈಡ್ಸ್ ಏನು ಫಾರ್ಮ್ ಆಗ್ತಾವಲ್ಲ, ಹೈಡ್ರೋಜನ್ ಮತ್ತೆ ಹೈಡ್ರೋಜನ್ ಜೊತೆ ಕ್ರಿಯೆ ಉತ್ಪಟ್ಟಾಗ ಅವು ವಾಟರ್ ಡಿಸಾಲ್ವ್ ಆಗಿ ಹೈಡ್ರೋಹೆಲಿಕ್ ಆಸಿಡ್, ಹೈಡ್ರೋಜನ್ ಇರ್ತದೆ, ಹೈಡ್ರೋಜನ್ ಇರ್ತದೆ, ಒಂದು ಆಸಿಡ್ ಆಗುತ್ತೆ. ಅಂತಾವೇನಾಗ್ತಾವಂತ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಾವೆ. Some important points related to this concept. Carefully observe this. What is the first point? The acidic strength of these acids. Acidic strength of these acids observed in the order of HF, hydrogen fluoride or hydrofluoric acid, is less than HCl, less than HBr, less than HF. That's very important points, please. See here, what is the point? Acidic strength or acidic nature of these hydrohalic acids is observed in the order of HF is less than HCl, less than HBr, less than HI. Why I write like this? That is the students, we know what is an acid. An acid is a substance which donates a proton. Is it correct? Yes. An acid is a substance which donates a proton. Students, between HF and HI, HF is one of the weak acid and HI is one of the strong acid. Why? Remember one point. HCl, HBr and HI are completely undergo ionization when reacted with water. ಈ HCl, HBr ಮತ್ತು HI ಏನಿದಲ್ಲ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಅಯನೈಸೇಷನ್ ಒಳಪಡ್ತಾವ ಯಾವಾಗ when they are treated with water. But HF, it is partially ionized. One point next, HF is one of the weak acid than HI. Students, remember the acidic strength is also depends upon the bond strength. Weaker the bond strength, more will be the acidic strength. Remember this point. ಎಷ್ಟು ಮಟ್ಟಿಗೆ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ವೀಕ್ ಆಗ್ತದೆ ಹೋಗ್ತದೆ ಅಷ್ಟು ಏನಾಗ್ತದೆ acidic ನೇಚರ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತದೆ. In presence of HI, the atomic size of iodine is high or large. Iodine size ಏನಂದ್ರೆ ದೊಡ್ಡದು. ಹೌದಾ? iodine size ದೊಡ್ಡದಲ್ಲ. ಮತ್ತೆ HI ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಏನದ ಅಂತೀವಿ? ಸೈಜ್ ದೊಡ್ಡದಿರೋದ್ರಿಂದ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಏನಾಗುತ್ತೆ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗಿರ್ತದೆ. ಹೌದಾ? ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗೈತಿ ಅಂದ್ರೆ ಇಟ್ ಈಸಿಲಿ ಡೊನೇಟ್ ಎ ಪ್ರೋಟಾನ್. ನಮ್ಮ ಡೆಫಿನಿಷನ್ ಈಗ ಬಂತಲ್ರಿ ಈಗ. An acid is a substance which donate a proton. ಇಲ್ಲಿ ಇದರ ಸೈಜ್ ದೊಡ್ಡದಿರೋದ್ರಿಂದ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ವೀಕ್ ಇದೆ ಅಂತ ಗೊತ್ತಾಗಿತ್ತು. ಅದಕ್ಕಾಗಿ ಏನು ಮಾಡಿದ್ರೆ ಈಸಿಯಾಗಿ ಪ್ರೋಟಾನ್ ಅನ್ನ ಬಿಟ್ಕೊಡ್ತಾರೆ. ಬಟ್ ಹಿಯರ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ HF, HF ಏನಿರ್ತದೆ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಸ್ಟ್ರಾಂಗ್ ಇರ್ತದೆ. ಅದಕ್ಕಾಗಿ ಡ್ಯೂರಿಂಗ್ HF it is not easy to donate a proton. ಈ H ಅನ್ನ ಈಸಿಯಾಗಿ ಬಿಟ್ಕೊಡೋದಿಲ್ಲ. ಅದಕ್ಕಾಗಿ ಏನಾಗ್ತದೆ ವೀಕ್ ಆಸಿಡ್ ಅನಿಸ್ಬೋದು. ಎಸ್ ನಂಬರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, HF is weaker acid than HI because due to the greater atomic size of iodine, it easily donates a proton. But in presence of HF, it is not easy to remove the proton. And another point, HCl, HBr, HI, they undergo complete ionization when treated with water. And HF, it undergoes partial ionization. ಗೊತ್ತಾಯ್ತಾ ಇದು? HI ಸೈಜ್ ದೊಡ್ಡದ ಅಂತಂದ್ರೆ ಅವ್ರದ್ದು ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಏನಾಗ್ತದೆ ವೀಕ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ದೂರ ಇದ್ರೆ ಏನಾಗ್ತದೆ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ವೀಕ್ ಆಗ್ತದೆ. ನಮ್ಮ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಕಡಿಮೆ ಆಗಿರ್ತದೆ. ಅಂತ ಸಂದರ್ಭದಾಗ H ಈಸಿಯಾಗಿ ಅಂದ್ರೆ ಪ್ರೋಟಾನ್ ಅನ್ನೋದು ಈಸಿಯಾಗಿ ಡೊನೇಟ್ ಆಗ್ತದೆ. ಅದಕ್ಕಾಗಿ ಅದು ಎಸಿಡಿಕ್ ನೇಚರ್ ಪಡ್ಕೋತದೆ. ಇಲ್ಲಿ ಅದು ಪಾಸಿಬಲ್ ಇಲ್ಲ. ಯಾಕಂದ್ರೆ ಬಿಕಾಸ್ ಆಫ್ ಸ್ಮಾಲ್ ಸೈಜ್ ಆಫ್ ಫ್ಲೋರಿನ್ the bond strength become high. Therefore, it do not remove easily the proton. Next, another point. Stability of these acids is observed in the order of these acids is observed in the order of is different. Here HF is greater than HCl, greater than HBr, greater than HR. Yes. The stability of HF hydrofluoric acid is greater than HCl, greater than HBr, greater than HR. ಇಲ್ಲಿ acidic strength ಅನ್ನು ಉಂಟಾಯಿತು. ಬಟ್ ಇಲ್ಲಿ acidic strength ಅಂತ ಅಪೋಸಿಟ್. Why HF is more stable than HI? Students, remember one point. Due to the more difference in the electronegativity of electronegativity of due to the more difference observed in the electronegativity of upper halogens and hydrogen. Due to the more difference in the electronegativity of upper halogens and hydrogen, the above hydrogen halides are more stable than lower hydrogen halides. Lower hydrogen halides. ಇಲ್ಲಿ ನೋಡಿ ಇರೋ ಪಾಯಿಂಟ್ ಬರ್ತೇನೆ. Why the stability of the hydrogen halides is observed in the form of or in the order of HF is greater than HCl, greater than HBr, greater than HI. ಇಲ್ಲಿ ಯಾಕೆ ಬರ್ತದೆ ಅಂತಂದ್ರೆ ಈ ಪಾಯಿಂಟ್ ಇಂದ ಅರ್ಥ ಮಾಡಿಸ್ತಾರೆ. Due to the more difference in the electronegativity of upper halogens and hydrogen, the above hydrogen halides are more stable than lower hydrogen halides. Students, remember, fluorine is one of the more electronegative atom. Yes. If you move down the group in presence of certain group elements, what happens to the bond strength? Bond strength decreases. Means the bond strength of halogens decreases down the group. Bond strength decrease ಆಗೋದು ಬಂದತಿ ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ಸ್ಟೆಬಿಲಿಟಿ ಏನಾಗೋದು ಹೋಗ್ತದೆ, ಅದು ಕೂಡ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. Remember students, stability is directly proportional to the bond strength. Bond strength ಕಡಿಮೆ ಆಗ್ತದೆ ಅಂದ್ರೆ ಸ್ಟೆಬಿಲಿಟಿ ಕೂಡ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಅವಾಗ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗ್ತದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಸೈಜ್ ದೊಡ್ಡದಿರ್ತದೆ, ಹೌದಾ, ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಕಡಿಮೆ ಆಗ್ತದೆ. ಅಂತ ಸಂದರ್ಭದೊಳಗ ಅದರ ಸ್ಟೆಬಿಲಿಟಿ ಕೂಡ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗ್ತದೆ. HF is here, fluorine is one of the more electronegative atom. Therefore, it contains high bond strength. Therefore, the stability of this one is more. Due to decrease in the bond strength, the stability of these acids observed in this pattern. Okay, students, next another point, third one. Reaction with metals. Reaction with metals. What happens when halogens react with metals? Students, remember, halogens react with metals. Halogen reacts with metals. They form the metal halides. Metal halides like NaCl, ACl, etc. Students, remember, halogens react with metals and they form metal halides. Metal halides. And here one more important point to remember: halides. Halides of higher oxidation state. Halides of higher oxidation state of metals. As remember, halides of higher oxidation state metals having covalent nature. Next, another point: halides of lower oxidation state of metals. Lower oxidation state metals having ionic nature. You know, when the covalent bond is formed, when the ionic bond is formed. Covalent bond is formed due to the mutual sharing of electron, and ionic bond is formed due to the complete transformation of electron. ಇದು ಏನು ಹೇಳಕತ್ತದ ಅಂದ್ರೆ ನಮ್ಗೆ ಗೊತ್ತಾಗಲ್ಲ, ಹೆಲೋಜನ್ಸ್ ಮೆಟಲ್ಸ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದಾಗ ಮೆಟಲ್ ಹೆಲೈಡ್ಸ್ ಅನ್ನ ಫಾರ್ಮ್ ಮಾಡ್ತಾವ ಅಂತ ಗೊತ್ತದ. ಆ ಮೆಟಲ್ ಹೆಲೈಡ್ಸ್ ಅಲ್ಲಿ ಹೆಲೈಡ್ಸ್ ಏನಾಗಿರ್ತಾವ, ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಮೆಟಲ್ ಜೊತೆ ಇದ್ದಾಗ ಅವ್ರ ನೇಚರ್ ಕೋವೆಲೆಂಟ್ ನೇಚರ್ ಇರ್ತದೆ. ಅದೇ ತರ ಲೋವರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಮೆಟಲ್ಸ್ ಇದ್ದಾಗ ಅಯಾನಿಕ್ ನೇಚರ್ ದಾಗ ಇರ್ತಾರೆ. Let's take an example. SnCl4, is it right? And Pb Cl4. They are in higher oxidation state here, therefore they possess covalent nature. These are covalent nature. If you take SnCl2 and AgCl2, remember this point. But main point is halogens react with metals, they form metal halves. Okay, students, in this video, I only discussed the 3 points. One is oxidation state, and another reaction with hydrogen, and another one reaction with metals in presence of chemical properties. In next video, we will see some more concepts in presence of chemical properties. Thank you.